We're going to continue our study of polynomial equations. In this video, we're going to talk about how to solve polynomial equations. So to do this, what we do is we set the polynomial equal to 0. So when we solve, for example, linear equations, we might have a linear function such as this, 3x plus 3. In order to solve an equation that's linear, we need to change the value of y. And so we might get something like this, where y is technically 6, and then we can solve for a value of x. When it comes to polynomials, we don't set the y value equal to anything except 0. And by doing so, it allows us to determine a lot of key information about the actual function itself. So that is number one. So what we need to first talk about is what an expanded form of a polynomial is. An expanded form would be something like this, 2x squared plus 6x, and then we're going to set it equal to 0. All right, now, to solve this, we need to get it into factored form. Now, there's going to be several methods that allow us to factor. So far, we are only going to cover what we're going to determine it as the greatest common factor. So if we look up at this example here of 2x squared, this is really 2 times x plus 2 times 3 times x. So what we did is we broke the polynomial down into factored components. So what we want to do is look for what is common in both parts. So here's one part and here's the other part. So in this case, both of these have a 2 and both have an x. So whatever they have in common is going to be pulled out. And so in factored form, we're going to have 2x, and then whatever's left over goes inside the parentheses. So this x goes here, and this 3 goes here. And so this 2x times the parentheses of x plus 3 is our factored form. And this is how we use greatest common factor. We're going to cover other methods in future videos and other videos. So for now, just to explain the idea of how to solve a polynomial, this is our first introductory method. All right, now what we're going to do is each factor we're going to set equal to 0. So we have two factors here. We have a factor of 2x. So 2x equals 0, and now we're going to solve. And so we're going to divide by 2, and we get x equaling to 0. So one solution is 0. Now the other factor is x plus 3. So we're going to set that equal to 0. And then to solve, we would subtract 3 from both sides and get our solution of x equaling -3. Now, what these solutions mean is where the particular function is going to cross the x-axis. So it's going to cross at x equals 0 and x equals -3 here. Okay? So this particular function would look something like this. And right now, again, all we're concerned with is where it crosses the axis. We're going to do further studies to determine where the vertex goes as well. But for now, the main concept is just where does it cross the axis? And that's the solutions or the roots. A root is another word used to indicate where the solutions are. Now, in different types of problems, we're going to get a couple different types of factors, and I want to just go over them quickly. First is we may get a variable-only factor, which we saw in this example. This would be an example of a variable-only factor, where the variable term is equal to 0. So in this example, our two terms would be w equals 0. Really, there's a 1 out front, and we would divide both sides by 1, which still gives us w equals 0. So this one is very basic. We might see a variable factor where the coefficient is out front, and it could be a positive or negative number, but if you have a variable only, it just equals to 0. A more common factor would be something like w plus 1, which is related to what we saw here. So in this case, w plus 1 would equal to 0, and then we would do opposite the number to get our solution. And there are variations of this, which I'll go over in a second. Now, the next is you might get a factor such as this, where you have what's called a repeated factor. So in this case, there's two factors of x minus 1. Since they're both the same, we only need to solve one, and we get x equaling to 1. But what's interesting about a repeated factor is what happens on the actual graph. So this particular function, what we're going to learn over time is that it touches the value x equals 1, but it doesn't cross. And so a repeated factor is actually a turning point of a graph, which we'll get to in future videos. Now, there's another type of factor that you may see, and it might be something like this. If you have 3n plus 2 as a factor, well, how do we solve that? Well, what do? We set it equal to 0. So 3n plus 2 is equal to 0. We would subtract 2 and then divide by 3. And in this example, we would get a solution of negative 2/3. So these are 3 common types of factors that we're going to get. To get these factors, we're going to use a lot of different methods. Right now, we've only talked about the greatest common factor method, which I demonstrated here.